address is. So that's in kernel 32. So we can do that here. And so it's basically going to go through again and load in all of the e-process blocks. And once again, not very efficient. This probably should have been pared down to a single subroutine, but I took a shortcut and went ahead and just made it use the previous subroutine to get all the e-processes. And then once we have that, we'll go through and walk through the export table and find out which one of those modules has that, and then get the address. And that's something, as far as I know, that's not a standard WinBag feature. I don't know of any DLLs that let you just type in an arbitrary thing and look it up. But you can do it if you have the symbols, because it'll already be loaded into WinBag's memory. But if you don't have the symbol access from MSDN, then you'd have a hard time doing this. All right, so now it's grabbed that last process there on PID 314 just to look at it, and it's reading the PEB, process execution block, and trying to get the list of the loaded modules in that process, searching for kernel32.dll. Again, our serial port is cranking away over there on the VMware. I don't know why it's so slow. It seems like it ought to be faster if it's just a direct socket connection, but there is some sort of bottleneck. All right, so it found an instance and the base address of kernel32.dll at that 77E8000 there, and now what it's basically doing is going through the export table one at a time and trying to match load library A in one of those exports. So it's kind of a slow way to get it, but we do eventually come up with it, 77E8A254. So I've got one more quick demo before we run out of time here, and that is the ability to inject code from the debugger here into the user space of the target system. So in this case, I just have a simple little demo code that it just inserts a message box, basically shell code, into the remote system. So what we did here, I cheated a little bit for demo's sake. It would normally look up message box A, but as you saw, that takes us a long time, and I didn't really have time, so we went ahead and just defined that ahead of time. But after that, it puts that shell code for the message box into the shared user memory space. And then it goes and finds a suitable thread in an Explorer, and it uses an asynchronous procedure call as an APC, which is a concept that allows you to just arbitrarily add code to a thread for it to execute. The next time it goes into an alertable wait state, it will look at that APC queue, and then if there's any code in there, it'll run it. So that's what we've done, is we basically use the debugger to read those memory structures, and are actually, instead of putting kernel shellcode in, we're just directly manipulating the structures in the memory, which is kind of dangerous probably, but we went ahead and did it, and just as an example. So it says that it's inserted that APC into the queue, so we can go ahead and continue the execution, hit G, and we'll probably get one little message to tell us something, and that's a little bit of raw data that probably needs to be interpreted, but we'll go ahead and hit that again, and we'll go back to our VMware session, and it's gone ahead and popped up that message box for us. So we're about to run out of time. So basically, there's only a few features that are implemented in this, and just whatever's part of the API I try to do, and then macros, just as an example. But hopefully, other people will take it and extend it, maybe rewrite it in Python or something, actually clean it up. So we actually rebooted it over the debug console. So I will be available out in the hall if anybody has some questions, because we don't really have any time here, because the next person's got to get up here and start setting up for their talk. So thanks for coming to the talk, and have a good rest of the conference.